Hello, we are back. Find the right screen. All right, so this is lesson 6.2, inverse functions and relations. So we're first going to look at what are our objectives. Our objectives in this case are going to be find the inverse of a relation and a function, and then we're just going to determine whether the two functions or relations are inverses. All right, so our first vocabulary word is inverse relations. So it's just a set of ordered pairs obtained by exchanging the coordinates of each ordinary pair. So if you have a relation xy, then its inverse is going to be yx. You're just exchanging the x and the y's. That's all we're doing. So if you look at the key concepts, they tell you two relations are inverse relations if and only if whenever one relation contains the element AB, the other one must contain the element BA. They don't say must. I put that in there just to emphasize that. All right, so let's look at example 1. So they give us the vertices of triangle ABC. And they want us to find the inverse of this relation. So first we're going to graph. So we have got coordinates, so we know how to graph coordinates. Let's use red. 1, -2, 2, 5. This is 5, yes. And then 4, -1. And we see we have a triangle, okay? So now they want us to graph the inverse of this relation. So let's find it. Pick up, there you go, green. So remember, these are the x, y's. And so to find the inverse, we just simply swap the x, y's. That's all we're doing. It's as simple as that. It's not complicated. It sounds like it's complicated, but if we just look at it, it's really just basic. So let's graph them now. -2, 1, and then 5, 3, 4, 5, 2, and -1, 4. So there you go. There you have the inverse of I don't know what's going on with my computer. So you have the inverse of this relation. So if we look at it here, there's the inverse. And it reflects, they don't tell you this, so you need to put this because it's not, I don't think they tell you in the book, but it reflects over the line y equals x. So if I had graph paper and I graphed this and I graph the line y equals x very precisely along with the coordinates, and then I folded it along this line and folded it up and used a Sharpie to trace this, we would get this. Intuitively doesn't look right, but that is what happens. Okay, so pause this, do guided practice 1, and we'll move on to the next thing. All right, so then we have properties of inverse relationships. So what are some properties? So if you look at the key concept box on page 2, it says if f and f of -1, which is the way you represent an inverse, are inverses, then f of a equals b if and only if the inverse of b equals a. So they're just saying if you swap the y's and x, which they just told us. So let f of x equal x minus 4 represent its inverse as x plus 4. So we're going to evaluate f of 6, and we get 2. And then we're going to evaluate f of 2 on the inverse, and we should get 6, and we do. So both of these are inverses. So that's one way of checking it. Okay, so when the inverse of a function is a function, the original function is a 1-to-1. This goes way back at the beginning of the year. So recall we can use a vertical line test, right? If it only goes through once and the relation or the graph or the equation or is a function. Similarly, we can do a horizontal line test to see if the inverse is a function. So if you take the function and you do a horizontal line test, if it only goes through once, then its inverse is also a function. So this right here, no matter where you go, it only goes through once, therefore its inverse is a function. Here, the function, the line passes through more than once, so its inverse will fail the vertical line test. So it is not a function. So just because the original equation is a function doesn't mean that its inverse is a function. It can be, but we have to check it. So let's look at example 2. It says find the inverse of each, then graph the function. So now let's go. We use relations, so now let's use functions. And how would we find the inverse of this? So they give us the function is f of x equals 2x minus 5. Okay, this is a fancy word for y equals 2x minus 5. So what we're going to do is we're going to swap the x and the y and then solve for y. Well, because I'm solving for y, I'm going to just flip the whole equation, which I have a property that says I can do that. And I'm just using algebra now, is what we're using to solve for y. So y equals 1/2 x plus 5/2. That is the inverse. So they want us to graph them both. So let's graph the original function. So we're going to go to -5, right? 5, 4, 3, 2, 1. And then we're going to go 1, 2, 3, 4, 5, 6. So -5, go up 2 over 1, up 2 over 1, up 2 over 1. Okay? And that's not the best, but then we connect the lines. Okay? So now let's graph this. So the 5 and 5/2 is 2.5. So we're going to go 1, 2, 3, 4. So about right here. And we're going to go up 1 over 2. Up 1 over 2. And then we connect the dots. That's the inverse. And then if we decide we want to go one further, we can, if we graph y equals x, and if you fold it along this line, it doesn't look like it, but this will become that. It will slip over that. Okay, so let's try B. So B says, I'm just going to go ahead and write y. Y equals x squared plus 1. So we're going to swap and say x equal y squared plus 1. Again, I'm going to do y squared plus 1 equal x minus 1 minus 1. Y squared equals x minus 1. We take the square root, so we get y equals, when we're solving, we get plus or minus the square root of x minus 1. So if we graph the original problem, it's a parabola that starts here and does this. Okay, then if we graph this, so these are two equations. So remember, this is square root of x minus 1 and negative square root of x minus 1. Well, that means it went to the right one, right, for the positive, and then the negative is just it reflects over the x-axis. So here's your two equations. So this is a function and its inverse. This is a function. It fails a horizontal line test, so it's inverse, and we can double check that, right? We do the vertical line test on its inverse graph, and it fails the vertical line test. So it is not a function. All right. So stop this and do the guided practice. And there's one more thing that we have to do here. Is example 3, our inverse function. So let's look at that key concept box. So it says this is another characteristic of an inverse function. If two functions f and g are inverses, if and only if both of their compositions are the identity function, which means so basically what they're saying, if you do fog of x and goff of x of the two functions, and you get x, then they're inverses. So they give us two equations and say, are these inverses of each other? You must do FOG for both of them. They can't be positive. They can't be negative x. They have to be positive x. They can't be negative x. They can be 1 over x, x to the negative 1, x squared, just positive x. Okay, so let's look at an example. It says they want us to determine, are these two functions? So let's look at the equation. So they give us f of x equals 3x plus 9. And they say g of x equal 1/3 x minus 3. So the first thing we're going to do is FOG of x. Remember, it can be written as f of g of x. This helps us because we do order of operations, which means you start inside a parenthesis. So I'm going to start with g of x equals 1/3 x minus 3. Now I'm going to do f of g of x. Do a different color, blue. So I'm going to put this whole thing into f of x. So 3 times 1/3 x minus 3 plus 9. Now I simplify. So this equals x minus 9 plus 9, which equals to x. So far I'm good. I can't stop there. I must go back and do g of x. I'm just going to write this the best way. So I need to do GOF. All right. So I start with f of x, which equals to 3x plus 9. I'm going to take this now. I'm going to do g of f of x. And I'm plugging it into here. So I get 1/3 times 3x plus 9 minus 3. So this becomes x plus 3 minus 3. And I get, that cancels to 0, so I get x. So both their compositions, when I do them, give me x. So these two are inverses. And how can I prove that? What's another way of proving? Well, I change this to y equals 3x plus 9. Yes, I swap and say x equals 3y plus 9. And then 3y plus 9 equals x. 3y equals x minus 9. Y equals 1/3 x minus 3. Isn't that what that is? Yes. You're like, well, why can't you have just done that from the first place? Well, you could have some complicated thing and it's just easy. They just want you to know that when you do GOF, that's another way. So let's look at B. So determine if f of x equals 4x squared and g of x equals 2 squared root of x are inverses of each other. So first I'm going to do f FOG. So I start with g of x, 2 square root of x, and I do f of g of x equals 4 times 2 square root of x squared. So this equals to 4, and this equals 2 times 4x, which equals to 16x. That does not equal to x, so I can stop there and say they are not inverses because both of them have to equal to x, and they don't, you stop there. Okay, stop the video. There is 2 guided practice, 3A and 3B, and then we will see you at the next in class.